So today let us discuss the remaining questions of double integral. There were 13 to 14 more questions in this topic. So let's complete this topic today. So the question 1 says that by using transformation, that is these transformation, we are supposed to evaluate this integral, and the region over which this integral is evaluated is also given. So this is the region. First let's draw the region. So it will be, if this is my x-axis and this is y-axis, then x equals to 0, that is this, y equals to 0, that is this, and x plus y equals to 1, that is this line. So we are supposed to evaluate the integration over this shaded region. Let's denote it with r, and this region is before transformation. After transformation also we need to see like what will be the region over which we are supposed to evaluate the integral. So the integration is double integration over region r, xy into 1 minus x minus y whole raised 1 by 2 dx into dy. So in the question itself they have given us the transformation that we are supposed to use. So that is u is equals to x plus y and y equals to uv. So this is the transformation, and since they have given us the value of y, we can easily calculate using this the value of x, that will be x is equals to u minus y, that is uv. So from here I got my x as u times 1 minus v and y as uv. So my Jacobian, that is del x comma y with respect to del u comma v will be del x over del u into del x over del v del y over del u into del y over del v, and it will be equals to del x over del u will be basically 1 minus v, del x over del v will be minus of u, del y over del u will be v, and del y over del v will be u. Now if we just simplify it, we'll get 1 minus v into u plus uv. That simplifies to u. So from here we got that d of x into d of y is basically u times du into dv. So the integration reduces to double integration. Let's say this time the region is r, that is post transformation. Let's assume that region is r dash. So it will be x into y, my x is u into 1 minus v and y is uv, times 1 minus x plus y is u, and whole raised 1 by 2 u dv. Now this simplifies to double integration over region r dash, u and u from here, so it is u square into 1 minus v into 1 minus u raised 1 by 2 into u du dv. That is equals to double integration over region r dash, u square into 1 minus u raised 1 by 2 into 1 minus v raised 1 by 2 du dv. Now if we just plug in the limits, first let's see what will be the change in region post transformation. So the region r dash of integration will be, if this is my x-axis and this as y-axis, so earlier the points are 0, 0, 1, 0 and 0, 1. So post transformation, when my x and y are 0 and 0, uv are also 0. Let's say this is u and this is vx. So there will be this point, let's name it as o dash, and when my x is equals to 1 and y is equals to 0, u is equals to 1 and v is equals to 0. So u is 1 and v is 0, that is this point. Let's name it as a dash. And when my x is equals to 0 but y is equals to 1, then u will be basically x plus y, that is 1, and v is x times y, that is 0. So the region is again 1, 0. This is the only point that we got. basically this line. So this will be our region that we are evaluating. I guess we calculated it incorrect, so it won't be this region. So let's evaluate it again. So it will be basically, if let's say this is my region, so post transformation my u is equals to x plus y, but my v is basically y by u. So, and the points in x y plane are 0, 0, 1, 0 and 0, 1. So when x and y are both 0, so u is 0 and v is 0 upon 0 form. So like there is no definite v in this case, and in this case my u will be 1 and v will be 0, and here my u will be again 1 and v will be 1 by 1, that is 1. So 1 by 1 will be somewhere here, 1, 1, if this is u and this is v, and 1, 0 will be somewhere here, 1, 0. Further these are bounded by u equals to 0, that is this line, and v equals to 0, that is this line. And when both u and v are 0, so in that case this is indeterminate form, so we can't say whether it will be infinity or 0. So this is the region over which we are basically evaluating. So let's just solve in the integration. So if you see that limit varies from 0 to 1, so it will be u square into 1 minus u raised 1 by 2 du, and limit of v also varies from 0 to 1, so it will be 1 minus v raised 1 by 2 dv. Now this is basically in beta function form, so if we simplify it further, we can write it as 3 minus 1 and 1 minus u into 3 by 2 minus 1 du, and this will be equals to 1 minus there is v as well here. Here also we missed a v, so it will be v raised 1 by 2. So it will be 1 minus v raised 3 by 2 minus 1 and v raised 3 by 2 minus 1 dv, integration from 0 to 1. So this will be equals to beta 3 comma 3 by 2 times beta 3 by 2 comma 3 by 2. So this simplifies to gamma 3 into gamma 3 by 2 divided by gamma 3 plus 3 by 2, that will be 9 by 2 times gamma 3 by 2 divided by gamma 3. This gamma 3 balances this, and gamma 9 by 2 can be written as, it is gamma 3 by 2 cube, and gamma 9 by 2 can be written as, we can use this relation, that is gamma of n is equals to n minus 1 into gamma of n minus 1. So using this relation multiple times, it can be 7 by 2 into gamma 7 by 2, 5 by 2 into gamma into 3 by 2 into gamma 3 by 2. So the final value will be basically equals to, it will be equals to gamma 3 by 2 square divided by 7 into 15, and in numerator there is 8. So this is the final value of the integration that we are solving. We can further evaluate it as gamma 3 by 2 will be equals to 1 by 2 into gamma 1 by 2. So it will be 8 into 1 by 4 into gamma 1 by 2 is under root pi, and under root pi square will give me pi divided by 7 into 15. So this 4 balances this, so it is 2 pi divided by 7 times 15, that is 105. So this is the final value of integration that we are solving. So let's move on to next question. So the next question says that evaluate this integration over region R, and region R is defined to us as this, like this. Over this bounded region we're supposed to evaluate. So first let us see what is our region R. So if this is y-axis and this is x-axis, so y is equals to x, that is it will be this line, and x is equals to pi by 2. So this line will be basically x equals to pi by 2. Further y is equals to 0, that is this line, and y equals to pi by 2, that will be this line. So the bounded region will be basically this triangle. So the integration is, let's name it as I, over region R, sine x by x into y dy dx. So let's plug in the limits. It will be equals to x is varying from 0 up till pi by 2, x is equals to 0 to pi by 2, and y is varying from 0 to x. So it is y into sine x by x dy dx. Now if we evaluate it, it will be integration x varying from 0 to pi by 2, and if we evaluate it with respect to y, it will be sine x by x into y limit from 0 to x dx. So it is equals to integration 0 to pi by 2 sine x by x into x dx, and this x balances the one in denominator. So we are left with integration from 0 to pi by 2 sine x dx, and integration of sine x will be cos x 0 to pi by 2, and cos pi by 2 will be I did it incorrect. Integration of y will be y square by 2. So it will basically reduce to, it will be y square by 2. So it will be, I can pull out 1 by 2, integration 0 to pi by 2 sine x by x into x square dx. So it is equals to, the one x in denominator balances one part, so we are left with 1 by 2 times integration from 0 to pi by 2 x sine x dx, and its integration will be 1 by 2 into let's do it by parts. We are assuming x as first function and sine x as second function. So we need to put in first function as same, and integration of second function, that will be minus of cos x, minus differentiation of first function, that will be 1, into integration of second, that will be minus cos x dx, and limit varies from 0 to pi by 2. Here as well it is 0 to pi by 2. So it is equals to 1 by 2, cos pi by 2 is 0, so this whole limit will approaches 0. So it is 0 plus integration 0 to pi by 2 cos x dx, and integration of cos x is basically sin x. So it is 1 by 2 into sin x, and x varies from 0 to pi by 2, and sin pi by 2 is 1 and sin 0 is 0. So whole integration is equals to 1 by 2. So now let's move on to the next question. So the next question says that evaluate this integral over the region R, which is bounded in between this and this. So it is a repeated question. In that, first we'll draw the figure, and it will be somewhat like this region, and we're supposed to evaluate it over this region. So for that we need to assume it adds u square and then proceed. So it is a repeated question. So let's move on to the next question. So the next question says that change the order of integration and evaluate this integral. So we are supposed to first change its order. Currently it's dx and dy. We are supposed to change it to dy dx and then evaluate it. So the integration is integration from -2 to 1, and x varies from y square to 2 minus y dx dy. So changing order of integration. So in order to change integration, first let us see the bounded region over which we are integrating it. So if this is my x-axis and this is my y-axis, so y varies from -2 to 1. Let's say -2 up till 1. So this point is -2 comma 0 comma 0 comma -2, and this is 0 comma 1, and x is equals to y square, and x is equals to 2 minus y. So another line is basically x, in this will give me x plus y equals to 2. So it will be somewhat like this. Let me just remove this point from here. So it will be somewhat like this, and this point is 0 comma 1. This is 2 comma 0, and here we have 0 comma 2. And another is this parabola y square equals to x. So it will be like this. So we are supposed to evaluate this over the shaded region. I am shading the region over which we are integrating it. So the region I shaded in red color is the region. So in order to change its order of integration, so it will be dy times dx, and y is varying from, like, we need to segregate it into two parts, because up till this part y is this parabola, and post this part lower limit of y is parabola and upper limit of y is this line. So let's name these region, this one as R1 and this one as R2. So if it is whole region is R, so this is equals to integration over R1 dy dx plus integration over R2 dy dx. Now let's plug in the limits. So it will be in region R, y is varying from minus of root x up till root x, and x varies from 0 to this point. And now we need to calculate what will this be. So for that, it is basically integration of this and this. So from here my x is 2 minus y is equals to y square. So that basically gives me y square plus y minus 2 equals to 0. That is equals to y square plus 2y minus y minus 2 equals to 0. So from here I can pull out y, it will be y plus 2, and from here I can pull out minus 1, so again it will be y plus 2. So from here I'll get y plus 2 into y minus 1 equals to 0. So that gives me y equals to minus 2 or y equals to 1. So when y is 1, my x is also 1, and when y is minus 2, x is basically 4. So we got basically these points. So this point is 1 comma 1, and this point is basically 4 comma minus 2. So x varies from 0 to 1 dy dx plus in region R2, my y is varying from this, that is under root of x minus of under root x up till this, that is 2 minus x dy, and x is varying from 1 up till 4. So x is varying from 1 to 4. Now let's just evaluate this integration. So it will be integration from 0 to 1 y limit from minus root x to under root x dx plus integration from 1 to 4 y limit from minus root x to 2 minus x dx. So it is equals to integration from 0 to 1 under root x plus under root x dx plus integration from 1 to 4 2 minus x plus under root x dx. So it is equals to integration from 0 to 1 2 under root x dx plus integration from 1 to 4 2 minus x plus under root x dx. So if we evaluate it, it will be 2 into x raised 3 by 2 divided by 3 by 2, limit from 0 to 1, plus 2x minus x square by 2 plus x raised 3 by 2 over 3 by 2, and limit from 1 to 4. So it will be 4 by 3 into 1 plus 2 into 4 minus 1 by 2 into 4 square, that is 16, minus 1 square, that is 1, plus 2 by 3 into 4 raised 3 by 2 minus 1 raised 3 by 2. So this simplifies to 4 by 3 plus 6 minus 15 by 4 plus 2 by 3 into 8 minus 1, that is 7. And it simplifies to 4 by 3 plus 6 minus 15 by 4 plus 7 to the 14 by 3. And 4 by 3 plus 14 by 3 will be 18 by 3, that is 6, and 6 plus 6 12 minus 15 by 4, and 12 times 4 is 48 minus 15 divided by 4. So that is equals to here we have a 1 by 2, it is 15 by 2, so it will be 24 minus 15 by 2, that is 9 by 2. So the answer of the given integration is basically 9 by 2. We can do it like without changing order of integration as well, but in that case these limits will differ, so you need to check on that. So let's move on to the next question. So the next question says that evaluate this integration where D is region bounded by this line and this parabola. So let's first plot in the region D over which we are integrating, because only then we will be able to get the limit of integration. So the region is, first is line, so this is my x-axis and this is my y-axis. So this line is basically x minus y is equals to 1. So it will be this line, and there is a parabola that has a vertex as like this. So this is the shaded region, like the region I am shading with red colored pen is the region R over which we are integrating, is the region D over which we are integrating it. So first let us find out the endpoints, that is the point where these two given curves are intersecting. So for that, first curve is x minus y equals to 1 and second is y square is equals to 2x plus 6. So from here I can put value of x in this equation, so that gives me y square equals to 2 times 1 plus y plus 6. So y square is equals to 2y plus 8. So from here I will get my y square minus 2y plus 1 is equals to 9, that is y minus 1 square is equals to 9. That is y minus 1 is equals to plus minus 3, and from here y is 1 plus minus 3, that is equals to either 4 or minus 2. So when y is equals to 4, my x is 5, and when y is equals to minus 2, x is minus 1. So this point is minus 1 comma minus 2, and other point is 5 comma 4. This is 5 comma 4. Now in order to evaluate it, we need to break it in two parts. This is region D1 and this is region D2. So our integration will be basically, I guess there is no need to distribute it in two parts, because we can take, like, we can change the order of integration. So it will be xy into dx dy. So y is varying from, like, this point, that is -2 up till 4. So y is varying from -2 up till 4, and x is varying from this point, that is point on parabola, to this point, that is point on line. So x is varying from y square minus 6 by 2 up till y plus 1. Now if we evaluate it, it will be -2 over 4 y into x square by 2, limit is y plus 1, y square minus 6 by 2 dy. This simplifies to, I can pull out 1 by 2 out of integration sign, so it reduces to -2 to 4 y into y plus 1 square minus y square minus 6 by 2 whole square dy. And this simplifies to 1 by 2 times integration from -2 to 4 y into y square plus 1 plus 2y minus y4 by 4 plus 9 minus 6y square. Minus 3y square it will be. So it is equals to 1 by 2 integration from -2 to 4 y times y square plus 1 plus 2y minus y4 by 4 minus 9 plus 3y square dy. And it is equals to 1 by 2 integration from -2 to 4 y times y square plus 3y square is 4y square, 1 minus 9 is -8 plus 2y minus y is 4 by 4 dy. Now this simplifies to 1 by 2 integration from -2 to 4, 4y cube minus 8y plus 2y square minus y is 5 by 4 dy. And this is equals to 1 by 2 4y is 4 by 4 minus 8y square by 2 plus 2 times y cube by 3 minus 1 by 4 into y is 6 by 6 integration from -2 to 4. This simplifies to 1 by 2 y is 4 minus 4y square plus 2 by 3 y cube minus 1 by 24 y is 6 and limit from -2 to 4. Now we can plug in the limits. It will be 1 by 2 into 4 raised 4 minus 2 raised 4 minus 4 into 4 square, that is 16, minus -2 square, that is 4, plus 2 by 3 into 4 cube, that is 64, plus 2 cube, that is 8, minus 1 by 24 into 4 raised 4 minus 2 raised 4 raised 6 minus 2 raised 6. Now you can just simplify this and it will be equals to 1 by 2 times 4 raised 4 minus 2 raised 4 is basically 240 minus 4 times 16 minus 4 is 12 plus 2 by 3 into 64 plus 8, that is 72, minus 1 by 24 into 4 raised 6 minus 2 raised 6, that is 4032, and this simplifies to 1 by 2 into 3, it will be 2 4, and 4032 divided by 24, this gives us 168. So this simplifies to 240 minus 4 into 12 plus 24 into 2, that is 48, minus 168, that is 72, and 72 by 2 is basically 36. So 36 is the final value of integration. So now let's move on to the next question. So the next question says that evaluate this integral, and we are evaluating it as dy by dx by changing order of integration. So like after changing order of integration, it will be 0 to infinity, 0 to y, x e raised minus x squared by y dx dy. Now you can assume this x square as some t, and then you can easily evaluate it, and we have done this similar question earlier as well, so it is a repeated question. So let's move on to the next question. So the next question says that evaluate this integration over the triangle formed by these straight lines. So first let us just draw the triangle to get idea of the limits of x and y. So triangle is, first line is y equals to 0, that is this line. Second is x equals to 1, that is this line. And third is y equals to x, that is this line. So the region over which we are integrating is this. So let's name it as I over under root 4x square minus y square dx dy. So value of y is varying from, and this integration point is basically 1, 1. So value of y is, what we can do is we can change its order of integration. So let's write it as dy dx. So value of x is varying from 0 up till 1, and value of y is varying from 0 to x under root 4x square minus y square dy dx. So like while integrating it with respect to y, we'll treat x as constant, so it is under root a square minus y square, and its integration is basically equals to, like we have a direct formula to get it integral, so we'll use that. It is somewhat like y by 2 under root a square minus y square plus a square by 2 sine inverse y by a. So we'll use this here. So it will be integration from 0 to 1 y by 2 under root 4x square minus y square plus 4x square by 2 sine inverse y by 2x, and limit varies from 0 to x dx. So it will be equals to integration from 0 to 1. When I plug in limit, it will be x by 2 under root 3x square plus 2x square into sine inverse 1 by 2, and other term will be 0 only, so dx. So it is integration 0 to 1 under root 3 by 2 x square plus 2x square into sine inverse 1 by 2 is basically pi by 6. So it will be pi by 6 dx, and its integration will be under root 3 by 2 into x cube by 3 plus pi by 3 into x cube by 3, and limit varies from 0 to 1. So it will be 1 by 2 under root 3, 1 minus 0 plus pi by 9 into 1 cube minus 0 cube, that is 1. So it is 1 by 2 under root 3 plus pi by 9. So this is the final value of integration that we are supposed to evaluate. Now let's move on to the next question. So next question says that evaluate this integration over region D, and region D is defined as a bounded region by given parabola. So first let's just draw the figure. So the parabola y equals to 2x square will be this, somewhat like this. So it is y equals to 2x square, and parabola y equals to 1 plus x square will be somewhat like, let's say this. This is y square, y equals to 1 plus x square. So we are supposed to evaluate the bounded region in between these parabolas, that is the shaded region by red color. So this is our region D over which we are evaluating our integral. So integral is, let's name it as I over region D x plus 2y into dA. So x varies from, first let's just calculate its point of integration. So that will be 2x square equals to 1 plus x square. That gives us x square is equals to 1. So from here we'll get x as plus minus 1. So when x is 1, y is 2, and when x is minus 1, again y is 2. So it is, this point is minus 1 comma 2 and this is 1 comma 2. So it is equals to integration from minus 1 to 1, that is value of x, and y is varying from 2x square up till 1 plus x square, x plus 2y into dy dx. Now if we evaluate it, it will be equals to integration from minus 1 to 1, xy plus y square, and limit varies from 2x square to 1 plus x square dx. Now if I simplify it, it will be minus 1 to 1, x into 1 plus x square minus 2x square plus 1 plus x square whole square minus 2x square whole square dx. Now this simplifies to integration from minus 1 to 1, x into 1 minus x square plus 1 plus x raised 4 plus 2x square minus 4x raised 4 dx. That is equals to integration from minus 1 to 1, x minus x cube plus 1 plus 2x square minus 3x raised 4 dx. Now if we evaluate it, it will be equals to x square by 2 minus x raised 4 by 4 plus x plus 2 by 3x cube minus 3 by 5 into x raised 5, and limit from minus 1 to 1. So if we plug in these limits, power of this is even, so it will be 0, and likewise here also it will be 0. So we are left with 2 plus 2 by 3 into 2 minus 3 by 5 into 2. So it will be 2 plus 4 by 3 minus 6 by 5. That evaluates to, if I take 15 as LCM, it will be 30 plus 5 was a 20 minus 18. That is 32 by 15 is the final answer. So next question says that evaluate this integration where over region R, and region R is inside a unit square in which x plus y is greater than or equals to 1. Okay, so the region R over which we are integrating is, first let us assume that this is a unit square. So this point will be 1 comma 0 and this will be 0 comma 1, and here we'll have 1 comma 1. And another line that is given to us is x plus y equals greater than equals to 1 by 2. So this is line of x plus y equals to 1 by 2. So the region over which we will be evaluating the integration will be this region that is shaded with R. So in order to check, like post drawing, in order to check what is our region in such cases, so the best thing to do is either put the any point and see like if it satisfies the relation or not. For example, if I put 0, 0 here in this equation, it will be 0 greater than equals to 1 by 2. So this, like this side of a square cannot be part of my integrable region. However, if I put point as 1, 1, so it will be 2, which is greater than or equals to 1 by 2. So my region is basically away from the origin. So this is one way to verify if you are integrating over the right region or not. So let's evaluate it and see what we get. So the region is, let's name it as I over region R, x minus y plus 1 into dx times dy. Now in order to evaluate it, we need to reduce it in two regions. Let's name this as R1 and this is R2. So the integration will be integration over region R1 x minus y plus 1 dx dy plus integration over region R2 x minus y plus 1 into dx dy. So now let's plug in the limits of region R1 and R2. So if you see that this point is basically 1 by 2, 0. So in region R1, x is varying from 0 to 1 by 2 and y is varying from 1 by 2 minus x up till 1, x minus y plus 1 into dy dx, plus in region R2, x is varying from 1 by 2 to 1 and y is varying from 0 to 1, x minus y plus 1 into dy dx. Now let's just evaluate this. So it will be integration from 0 to 1 by 2, x plus 1 times y minus y square by 2, limit from 1 by 2 minus x up till 1 dx, plus integration from 1 by 2 to 1 and x plus 1 times y minus y square by 2. This time limit is from 0 to 1 dx. Now if we evaluate it, it will be 0 to 1 by 2, x plus 1 times 1 minus 1 by 2 plus x minus 1 by 2 into 1 minus 1 by 2 minus x square dx, plus integration from 1 by 2 to 1, x plus 1 minus 1 by 2 dx. Now that simplifies to integration from 0 to 1 by 2, x plus 1 into x plus 1 by 2 minus 1 by 2 into 1 minus 1 by 4 minus x square plus x dx, plus integration from 1 by 2 to 1, x plus 1 by 2 dx. Now this simplifies to integration from 0 to 1 by 2, x square plus x by 2, that is 3x by 2 plus 1 by 2 minus 1 by 2 plus 1 by 8 plus x square by 2 minus x by 2 dx, plus integration from 1 by 2 to 1, x plus 1 by 2 dx. That simplifies to this 1 by 2 balances this. So we are left with integration from 0 to 1 by 2, x square plus x square by 2 is 3x square by 2 and 3x by 2 minus x by 2 is x plus 1 by 8 dx, plus integration from 1 by 2 to 1, x plus 1 by 2 dx. Now if we integrate it, it will be 3 by 2 into x cube by 3 plus x square by 2 plus x by 8, value from 0 to 1 by 2 plus x square by 2 plus x by 2, integration from 1 by 2 to 1. So this simplifies to 1 by 2 into 1 by 8 plus 1 by 2 into 1 by 4 plus 1 by 16 plus 1 by 2 into 1 minus 1 by 2, that is 1 by 2. 1 minus, it will be 1 minus 1 by 4, that will be 3 by 4 plus 1 by 2 into 1 by 2. So this is equals to 1 by 16 plus 1 by 8 plus 1 by 16 plus 3 by 8 plus 1 by 4. Now 1 by 16 plus 1 by 16 is 1 by 8 plus 1 by 8 plus 3 by 8 plus 1 by 4. So this is 3, 4, 5. 5 by 8 plus 2 by 8, that is 7 by 8. So 7 by 8 is the final answer of this integration. So now let's move on to the next question. So the next question says that evaluate this integration over the area which lies in between these two curves. So first let's see the region or area over which we are supposed to evaluate the integration. So this is my x-axis, this is my y. First line is y is equals to x, that is this line, and second is y equals to x square, that is a parabola, like this parabola. So we're supposed to evaluate it over area in between these two curves, that is the region. I am shading with red colored pen. So this is the area or region R, let's say, over which we're supposed to integrate. So let's just calculate the intersection points. So that will be x square is equals to x. So from here I got my x equals to 0 or x equals to 1. So when x is 0, y is 0, and when x is 1, y is 1. So this point is 1, 1, and this is basically 0, 0. Now the given integration is, let's name it as I. It is integration over region R, xy, x plus y into dx dy. Now if you see that my x is varying from this point 0 to this point 1, that is x is varying from 0 to 1, and y is varying from this point up till this point. So y is varying from x square to x, and we are integrating xy into x plus y dx, dy into dx. Now I can write it as integration over 0 to 1 x square x, x square y plus xy square dy dx. Now this simplifies to integration from 0 to 1 x square into y square y2 plus x into y cube by 3 over region x square to x dx. Now that simplifies to integration from 0 to 1 x square by 2 into x square minus x raised 4 plus x by 3 into x cube minus x raised 6 dx. This is equals to integration over 0 to 1 x raised 4 by 2 minus x raised 6 by 2 plus x raised 4 by 3 minus x raised 7 by 3 dx. Now if we simplify it, we'll get integration over 0 to 1. We can club in these two terms. It will be 5 by 6 x raised 4 minus x raised 6 by 2 minus x raised 7 by 3 dx. So it will be equals to 5 by 6 into x raised 5 by 5 minus 1 by 2 into x raised 7 by 7 minus 1 by 3 into x raised 8 by 8. Integration from 0 to 1. So this is equals to 1 by 6 minus 1 by 14 minus 1 by 8 3 is 24. And that simplifies to this, and this term will be 4 by 24, that is 3 by 24 minus 1 by 14, which is equals to 1 by 8 minus 1 by 14, and it's 8 into 7, that is 7 minus 4, which is equals to 3 by 56. So this is the value of integration over region R, that is this shaded region lying in between parabola and a line y equals to x. So let's move on to see the next question. So the next question says that evaluate the double integral, basically this, by changing the order of integration. So in the question they have said that if I is my integration with limit of y from 0 to a and limit of x from y to a, x dx dy by x square plus y square. So we are supposed to evaluate it by changing order. So in order to change its order of integration, first let's draw a figure. So x is varying from y up till a. This will be line y equals to x, and x is equals to a will be, let's say, this line, and y equals to a will be this line. So we are integrating it over this region that I am shading with red color. So now let's change its order of integration. So if you see that x is varying from 0 till a, so x equals to 0 up till a, and y is varying from y equals to 0 to y equals to x. X dx dy divided by x. It will be dy by dx because we have changed the order of integration. So it is x dy dx. That equals integration from 0 to a, and if I integrate it with respect to y, it will be tan inverse y by x into 1 by x, and limit varies from 0 to x dx. Now this x balances out this one, so we are left with integration from 0 to a tan inverse 1 minus tan inverse 0, and tan inverse 1 is basically pi by 4 and tan inverse 0 is 0 only, so it is equals to integration from 0 to a pi by 4 minus 0 dx, so it is equals to pi a by 4. So this is the final value of integration that we're supposed to evaluate. So, and you can also verify it by integrating it with this order only. That will also give you the same answer. So let's move on to next question. So the next question says that obtain the value of double integral this over region D, and D is represented by region bounded by the straight line y equals to x and the parabola y square is equals to 4x. Now if you see that this is a similar question to this one, so let's see. Let's first draw the figure. So it is, so line y equals to x will be this line, and the parabola y square equals to 4x will be somewhat like this. So we are evaluating it over this region. Basically region D is this shaded region. This is D. Now let's just find out the point of integration of this line y equals to x and the parabola. So that will be y square is equals to 4y. So from here I'll get my y equals to 0 or y equals to 4. So when y is 0, x is also 0, and when y is 4, x is also 4. So the integration will be, let's name it as I, integration over region D, x square plus y square into dx dy. Now let's see what will be the limits. So y is varying from 0 up till 4, and x is varying from this point to this point. So that is y square by 4 up till y, and we are evaluating x square plus y square dx dy. Now if I integrate it with respect to y, so it will be x cube by 3 plus y square x integration from y to y square by 4 dy. Now let's just plug in the limits. It will be integration from 0 to 4, 1 by 3 into y cube minus y raised 6 by 4 cube, that is 64, plus y square into y minus y square by 4 dy, and it will be equals to integration from 0 to 4 y cube by 3 minus y 6 by 64 into 3, that is 180 plus 12, 192, plus y cube minus y raised 4 by 4 dy. Now if I solve it, it will be basically y raised 4 by 12 minus y raised 7 by 192 into 7 plus y raised 4 by 4 minus y raised 5 by 5 4s are 20, and limit varying from 0 to 4. So it is equals to I can club in these two terms. So it will be y raised 4 by 3 minus y raised 7 by 192 into 7 minus y raised 5 by 20, and limit of y varies from 0 to 4. So it will be equals to 1 by 3 into 4 raised 4 minus 192 into 7 into 4 raised 7 minus 4 raised 5 by 20. And you can use calculator to simplify it, or what we can do is we can pull out 4 raised 4. It will be 1 by 3 minus 4 raised 3 by 192 into 7 minus 4 by 20, that will be 1 by 5, and this simplifies to 4 raised 4 will be 256, 1 by 3 minus 1 by 5 minus 4 cube by 192 into 7 is, we can write it as 4 square into 4, and this will be 4, 8, again one power balance is 1, 2, 1, 3, so it will be 1 by 21, and that simplifies to, if I take LCM, it will be 256 into 5 into 21, that is 35 minus 21 minus 5, that is equals to 256 into 35 minus 21 is 14, and 14 minus 5 is 9 by 5 into 21, and this reduces to 256 into 3 by 35, and this is the final answer of the integration that we were evaluating. So let's see next question. I guess this is the last question. This completes our topic of double integration. So tomorrow we'll see questions related to triple integration. There were only 2 to 3 questions asked on that topic. That's not asked quite frequently. So thank you for watching, and please do like, share and subscribe the channel.